An Ekranoplan, also known as the ground effect vehicle, is a vehicle that is able to move over the surface by gaining support from the reactions of the air against the surface of the earth or water. Typically, it is designed to glide over a level surface by making use of ground effect, the aerodynamic interaction between the moving wing and the surface below. Some models can operate over any flat area, such as frozen lakes or flat plains similar to a hovercraft. A ground effect vehicle needs some forward velocity to produce lift dynamically, and the principal benefit of operating a wing in ground effect is to reduce its lift-dependent drag. The basic design principle is that the closer the wing operates to an external surface, such as the ground, when it is said to be in ground effect, the less drag it experiences. An airfoil passing through air increases air pressure on the underside, while decreasing pressure across the top. The high and low pressures are maintained until they flow off the ends of the wings, where they form vortices, which in turn are the major cause of lift-induced drag, normally a significant portion of the drag affecting an aircraft. The greater the span of a wing, the less induced drag created for each unit of lift, and the greater the efficiency of the particular wing. This is the primary reason gliders have long wings. A GEV is sometimes characterized as a transition between a hovercraft and an aircraft. Although this is not correct, as a hovercraft is statically supported upon a cushion of pressurized air from an onboard downward-directed fan. Some GEV designs, such as the Russian Lun and Dingo, have used forced blowing under the wing by auxiliary engines to increase the high-pressure area under the wing to assist the takeoff. However, they differ from hovercraft in still requiring forward motion to generate sufficient lift to fly. Although the GEV may look similar to the seaplane and share many technical characteristics, it is generally not designed to fly out of ground effect. It differs from the hovercraft in lacking low-speed hover capability in much the same way that a fixed-wing airplane differs from the helicopter. Unlike the hydrofoil, it does not have any contact with the surface of the water when in flight. The ground effect vehicle constitutes a unique class of transportation. They have three types of wing configurations: straight wing, reverse delta wing, and tandem wings. Given similar hull size and power, and depending on its specific design, the lower lift-induced drag of a GEV, as compared to an aircraft of similar capacity, will improve its fuel efficiency and, up to a point, its speed. They are also much faster than surface vessels of similar power, because they avoid drag from the water. On the water, the aircraft-like construction of Ekranoplans increases the risk of damage in collisions with surface objects. Furthermore, the limited number of egress points make it more difficult to evacuate the vehicle in an emergency. Since most GEVs are designed to operate from water, accidents and engine failure typically are less hazardous than in a land-based aircraft, but the lack of altitude control leaves the pilot with fewer options for avoiding collision, and to some extent that negates such benefits. Low altitude brings high-speed craft into conflict with ships, buildings, and rising land, which may not be sufficiently visible in poor conditions to avoid. They may be unable to climb over or turn sharply enough to avoid collisions, while drastic, low-level maneuvers risk contact with solid or water hazards beneath. Aircraft can climb over most obstacles, but GEVs are more limited. For the vehicle to work, its hull needs to be stable enough longitudinally to be controllable, yet not so stable that it cannot lift off the water. That's all for today. See you in another video.